Hi, welcome to the math class. I am discussing about the new topic vector calculus. Our title of the paper is ring theory and vector calculus. Already we discussed about the ring theory. The topic is ring theory. Already we discussed it. Now we discussing about the topic is vector calculus. In this topic, we have to learn three subtopics. One is vector differentiation and vector integration and its applications. So these are different topics. In vector differentiation, we have to learn about differentiation of vectors. In this differentiation of vectors and gradient, some operators, and that is gradient, difference, divergence, curl, and some theorems on these operators, and some some theorems based on the operators. In vector integration, we have to learn about three different types of integrals. First one is line integral, and the second one is surface integral, and the third one is volume integrals. These three are the different types of integrals. The last topic we have to discussing about some topics, that is in vector integration applications. Uh, First one is Gauss divergence theorem, Gauss divergence theorem and its applications. And the next one is Green's theorem and its applications. And third one is Stokes theorem and its applications. These are the basic view of about these topics. One is vector differentiation, and vector integration, and its applications. Now, the first definition is vector function. Vector function. In this definition, let I bar, j bar, k bar be the three mutually perpendicular unit vectors in three-dimensional space. Then the vector function f bar of t may be expressed as f bar of t equals to, otherwise it is called r bar, that is equal to f1 of t into y bar plus f2 of t into j bar plus f3 of t into k bar, where f1 of t comma f2 of t and f3 of t are real valued functions, real valued functions over the variable t, and it is known as and it is known as coefficients of r bar, and it is known as coefficients or components of r bar. See, I bar, j bar, k bar be the three mutually perpendicular. Three means I bar, j bar, k bar. Mutually perpendicular means pairwise perpendicular, and that means I is perpendicular to j, and j is perpendicular to k, and k is perpendicular to I. This is the word mutually perpendicular means pairwise perpendicular. Unit vectors. Unit vector means the mod of I vector, j vector. The modulus of these vectors are 1. That is, I bar is equal to 1, mod j bar is equal to 1, mod k bar is equal to 1. Modulus of these three vectors are 1. That is the unit vector in three-dimensional space. Three-dimensional space means x bar, y bar, x axis, y axis, z axis. I vector is equal to x axis parallel to x axis, j vector is parallel to y axis, k vector is parallel to z axis. That function, that vector function f bar of t may be expressed as f bar of t is equal to r bar f1 of t I bar f2 of t j bar plus f3 of t into k bar, where the functions, real valued functions, are called f1 of t plus comma f2 of t and f3 of t are real valued functions over the variable t. ఇక్కడ నేను t తీసుకున్నాను కాబట్టి over the variable t, and it is known as the coefficients of r bar. And some properties, some conditions, some conditions. Already in intermediate we learn these topics. That is I bar dot I bar dot I bar I bar dot I bar is equal to 1. J bar dot J bar is equal to 1. K bar dot K bar is equal to 1. And I bar dot J bar is equal to 0. J bar dot K bar is equal to 0. K bar dot I bar is equal to 0. And this is the dot, this is called the dot product, dot product, or scalar product. Dot product or scalar products. Okay. And one more conditions. And I bar cross J bar is equal to K. J bar cross K bar is equal to I bar. K bar cross I bar is equal to J bar. And I bar cross I bar is equal to 0. J bar cross J bar is equal to 0. K bar cross K bar is equal to 0. అండ్ ఆల్సో దీన్ని మనం ఎలా రాసుకోవచ్చు, రివర్స్ రాసామనుకోండి ఎలా అవుతుంది ఇది, జే ఫ్రమ్ దిస్ జే బార్ క్రాస్ ఐ బార్ ఇజ్ ఈక్వల్ టు మైనస్ కే బార్. ఫ్రమ్ దిస్ రివర్స్ రాస్తే క్రాస్ ప్రోడక్ట్ని రివర్స్ రాస్తే కే బార్ క్రాస్ జే బార్ ఇజ్ ఈక్వల్ టు మైనస్ ఐ బార్. ఇక్కడ ఐ బార్ క్రాస్ జే కే బార్ దట్ ఈజ్ ఈక్వల్ టు మైనస్ జే బార్. ఇలా రివర్స్ రాస్తే, సో దిస్ ఈస్ కాల్డ్ క్రాస్ ప్రోడక్ట్. క్రాస్ నాట్ ఎక్స్, దిస్ ఈస్ కాల్డ్ ద క్రాస్ ప్రోడక్ట్ ఆర్ వెక్టార్ ప్రోడక్ట్. వెక్టార్ ప్రోడక్ట్, క్రాస్ ప్రోడక్ట్ ఆర్ వెక్టార్ ప్రోడక్ట్. దీనేమో డాట్ ప్రోడక్ట్ ఆర్ స్కేలార్ ప్రోడక్ట్, దీనేమో క్రాస్ ప్రోడక్ట్ ఆర్ వెక్టార్ ప్రోడక్ట్. ఓకే. And some definition, limit of a vector function, limit of a vector function. Let f bar of t be a vector function, be a vector function defined over the domain capital S, and we can take one element in the set capital S if there exists a vector L bar such that for each epsilon greater than 0, for each epsilon greater than 0, there exists some delta greater than 0 such that symbol వేసుకుంటే సరిపోద్ది, such that 0 less than mod t minus a less than delta, that implies mod f bar of t minus some L bar is less than epsilon, then the vector L bar is called the limit of f bar of t as t tends to some small a, and it is denoted by limit t tends to a, f bar of t is equal to L bar. So this is the definition of the limit of a vector function. Already this definition discussed in fourth semester, I think. A limit of a function, there exists some delta greater than 0 where 0 less than mod t minus a is less than delta. This is also can be written, it can be written as that implies, అంటే ఈ కండిషన్ జరగాలన్నమాట. లిమిట్ ఆఫ్ ఏ ఫంక్షన్ కి mod f of t మైనస్ ఎల్ బార్, ఆ ఫంక్షన్ కి మనం తీసుకున్న ఒక వేరియబుల్ కి ఎల్ కి మధ్య డిఫరెన్స్ లెస్ దాన్ ఎప్సిలాన్ ఉండాలి. అప్పుడు దట్ వెక్టార్ ఎల్ బార్ ఈస్ కాల్డ్ ద లిమిట్ ఆఫ్ ఏ ఫంక్షన్ f bar of t as a t tends to some a. So the a is the fixed element and it is denoted by limit t tends to f bar of t is equal to L bar. And some properties of limits. Properties of limits. Let limit t tends to a bar of t is equal to L bar, comma, limit t tends to a b bar of t is equal to m bar, and lambda is any non-zero real number. Then property 1, limit t tends to a bar of t plus b bar of t, that is equal to L bar plus m bar. And the second property, limit t tends to a lambda into where a bar of t, lambda is some parameter, that is equal to lambda into that variable. And the third point, limit t tends to a bar of t into into b bar of t, that is equal to L bar into m bar. And the next property, limit t tends to a bar of t cross b bar of t, that is equal to L bar cross M bar. This is the dot product L bar dot M bar. And the next property, limit t tends to a lambda into a bar of t plus some another variable delta into b bar of t ఇలా కనుక ఇస్తే అప్పుడు lambda into L bar plus delta into M bar, where delta is also not equals to 0, is also belongs to some real number. Is delta not equals to 0? It is a some real number. And the next definition, continuity of a vector function. Continuity of a vector function. Continuity of a vector function. Okay. Let f bar of t be a vector function, be a vector function on some an interval, on some interval capital I, and any element a belongs to that interval, then f bar of t is said to be continuous at small a if limit t tends to a, f bar of t is equal to f of a. That means continuity of a vector point means that limit is continuous at the point small a. It is true, for all a belongs to I. అంటే ఏ ఒక్కటే కాదు, ఏ ప్లేస్లో బి తీసుకున్న సీజ ప్రతి ఇంటర్వెల్లో ఏ ఎలిమెంట్ తీసుకుని ఈ కండిషన్ డన్ అనమాట. ద ఫంక్షన్ f bar of t is said to be continuous on the interval capital I if f bar of t is continuous at each point on capital I. So this is the definition of the continuity of a function. So here one important point, note point. ఒకవేళ if f bar comma g bar are two continuous functions కనుక ఉంటే, two continuous functions on the interval capital I, then f bar plus or minus g bar, f bar dot g bar and f bar cross g bar మొత్తం మూడు ఉన్నాయి are also continuous on the interval capital I. Okay. And one more definition, derivative of a vector function. Derivative of a vector function. Let f bar be a vector function, on an interval capital I, and some element a belongs to capital I if the limit t tends to a, f bar of t minus f bar of a by t minus a exits, then it is called then it is called the derivative of f bar. The derivative of f bar at the point small a, and is denoted by f bar dash, of a, or df bar by dt at the point t is equal to a. Okay, and also it is said that f bar is differentiable at t is equal to small a. Therefore, f bar dash of t, otherwise df bar by dt at t is equal to a దగ్గర limit t tends to a, f bar of t minus f bar of a by t minus a. So this is the some definition. Okay, and some important conditions, some properties, some properties some properties. First one is a very, very important point. If f bar of t is differentiable at the point t is equal to small a, then f bar of t is continuous at the point t is equal to a. And the second point, if f bar of t is continuous at t is equal to a, then f bar of t is need not be differentiable at t is equal to a. Okay, and the third point, if f bar of t is a constant function, then f bar of dash a is equal to 0. f bar dash అన్న f bar of dash అన్న లేకపోతే df bar by dt అన్న both are equal. Okay, and the next point, if f bar of రెండు తీసుకుందాం, if a bar of t and b bar of t or any two vector functions which are differentiable then the first point, d by dt of a bar of t plus or minus b bar of t, that is equal to d by dt of a bar of t plus or minus d by dt of b bar of t. And the second condition, d by dt of a bar of t dot b bar of t, that is equal to d by dt of a bar of t dot b bar of t plus a bar of t into dot dot d by dt of b bar of t. Okay, అంటే డాట్ ప్రోడక్ట్, ఇక్కడేమో క్రాస్ ప్రోడక్ట్ d by dt of a bar of t cross b bar of t, that is equal to d by dt of a bar of t cross b bar of t plus a bar of t cross d by dt of b bar cross t. Okay, and the next point, if fourth point, third and fourth point, if d by dt of a bar square is equal to 2 into a bar dA bar by dt. Okay, and the fifth point, next page lo raddam. And the fifth point, if f bar of t is a vector function, in the form f bar of t is equal to f1 of t into I bar plus f2 of t into j bar plus f3 of t into k bar, where f1 of t comma f2 of t comma f3 of t or functions over the variable t, then d by dt of f bar of t is equal to d by dt of f1 I bar plus df2 by dt into j bar plus df3 by dt into k bar. So that function is in the form of ఈ ఫంక్షన్ ఎలా ఉంటుంది అనమాట. And very very important note point, if f1 f2 f3 are constant functions, then f bar of t is equal to f1 of t into I bar plus f2 of t into j bar plus f3 of t into k bar is called a constant function, is called a constant vector function, that is df bar by dt is equal to 0. దీనికి ఒక ఎగ్జాంపుల్ ఇద్దాం. if f bar is equal to 3i bar plus 4j bar plus 5k bar, df bar by dt చేస్తే ఎంత అవుతుంది? ఇక్కడ t వేరియబుల్ లేదు కదా, కాబట్టి ఇప్పుడు ఏంటిది d by dt f bar అంటే 3i bar plus 4j bar plus 5k bar. t అనే వేరియబుల్ లేదు కదా, కాబట్టి విత్ రెస్పెక్ట్ టు t మనం చేయలేం, కాబట్టి దట్ వాల్యూ ఇస్ 0. Okay, so this is the way we have to solve any problem. First we learn the conditions of the vector point of a function. Okay, if you have any doubts, please WhatsApp me, I will respond immediately. Thank you so much.